Hi, this is Mr. Max. So what I'm doing right now is part 4 of my 5-part series on set notation Venn diagrams. So I'm doing the union and the intersection of sets in this particular video. So let's talk briefly about the union of two sets. It's the combination, sort of the coming together of the sets. So it's like a U shape, as you can see whenever you are doing that notation. So this is saying that the union of two sets is X such that X is an element of A or X is an element of B. We are going to look at a quick example here. So I have set X that has got the elements 3, 5, 6, 11, and 13. And also set Y that has the elements 11, 13, and 15. So we want to find the union of these two sets, everything that is in set X and Y. So you have to be a bit careful here. You will realize that I am not listing 11 and 13 twice, although it is appearing in both. So you just list them once only. So the union is everything that is in X and everything that is in Y. So you do not list them twice. This one is straightforward. You now have to find the number of elements that are here. And if you count, you will realize that you have 6 elements in that particular set of the union of X and Y. Right, we are going to do a little bit of shading. Now, shading is not going to be asked perhaps in the exam, but it's always worthwhile to know what it entails. So we're going to shade and break it into sort of 3 parts. So first what I'm doing here is I'm shading the region A, set A, and yellow, as you can see here. And now I'm going to do the region that is the complement of B, everything else that is not in B. And it's represented by this color, as you can see. So the union of A and the complement of B, therefore, will be this particular region that you see that is not shaded when you sort of join the two. And that is how you find that particular region. Let's bring in another one. We are now going to shade the complement of A with the union of the complement of B. So first of all, we're going to shade everything that is not in A, exactly like what we did before. And the second one is we're going to shade everything that is not in B, as you can see in yellow here. So when you sort of superimpose and put them on top of each other, you realize that the region that is not shaded is this region where the intersection is taking place. So the complement of A union B complement is this particular region here. So the union of the complement of A and B is this represented by this particular region that is not shaded. The intersection of sets, well, think about overlap. It's where you have non-disjointed sets, sets that have got something that they share. All right, so there is, for example, something that the two sets have in common. Let's look at a quick example now. What I did here is I have written down the universal set of elements from 1 up to 10. And then I have set P and set Q. I already highlighted in red what they have in common. So if you are asked to write down the intersection of set P and Q, that simply will be this particular values here in red. And on a Venn diagram, we'll represent them like that, where the overlap is actually taking place, the intersection. And everything of set P comes in the rest of the place, and everything set Q comes in the rest of the place. Now when you look at the universal set, you remember it's from 1 up to 10, but there are some values missing, and those values we put them inside the rectangle outside of the circles. Another example here, the same universal set of elements between 1 up to 10, we are supposed to find the intersect of P and Q. So we're looking for that value that they have that is in common. Well, if I bring my Venn diagram, I'll realize that set P has got the elements 5, 6, 7, and 10, and set Q has got 3 and 4. I can see that there is nothing that they have in common. But there are also some other elements that must come outside, and those are 1, 9, and 2, and 8, in order to complete the universal set. So when sets are like this, we call them disjoint sets. So that intersection is not there, or it's an empty set. Let's bring in a third example. So we're still dealing with the universal set of elements between 1 and 10, with 1 and 10 included. So when we draw a Venn diagram, the first thing is we want to find in set P the multiples of 3. In set Q, we have to find the prime numbers. So you must be a bit careful that there is something that they have in common. So suppose you were supposed to write down the multiples of 3 from this particular information here from the universal set. The multiples of 3 will be 3, it will be 6, and it will be 9. These will be the multiples of 3. And if you were supposed to write down the prime numbers, you will have 2, 3, 5, and 7. And then you will realize that there is something that they have in common. And what they have in common is this 3 here. And that 3 is going to be the overlap, as you can see, where the two sets are intersecting with each other. Now we're going to put everything else in the multiples of into P, 6 and a 9. And all the other prime numbers are now also going to be added to make up for the whole of set Q. So whatever is not there comes on the outside of the circles inside the rectangle. They are part of the universal. So all of these are representing universal set. So what is not in Q and P comes outside. And you can put them anywhere as long as it's within that area right there. So the intersection of the two sets is just 3. Let's do more examples. In each of the following cases, I'm asking to shade. It's just going to help you to be able to solve problems when you do examination type questions. And there is also something that you will realize when you do shade the following. You will realize that you are going to end up exactly with the same diagram, because the complement of A intersection B complement is everything that is not in the union of A and B. So you can always look at it in that particular way. And this is a very important thing to take note of. The same when we do this particular one here, you also will realize that the intersection of A and B complement is everything that is not in the complement where they meet or they overlap, and you shade everything on the outside. So these two statements are relatively equal to one another. So when you do get something like this, you should always know that you can do that. So what I did is I'm bringing in an example where I show how I use this information. So here you have a Venn diagram. They are saying you are supposed to write the letters P, and P is an element of the intersection of X, Y intersects Z. So basically what we are saying, P is every element. P is found in X, it's also found in Y, it's also found in Z. So that one is relatively straightforward. So it intersects with all three of the sets, and this is the region that shows that particular. The second one here is that relative one that I was talking about. So you have got the X complement intersect Y complement intersect Z complement. So basically I can take the union of everything and take what is not in the union using the previous example I was referring to. And that means that Q is not going to be represented anywhere else. Then the last one, so you find what is not in the union of X and Y, but it is intersecting with Z. So it's going to be appearing in this particular area. And this is a question where you get 1 mark each for putting these values at the right places, or these letters here. Let's bring in another example, 7. So you have got 3 sets, X, Y, and Z. So we are supposed to find the union of x and y. So that is easy. You just take the sets of x and y, and remember, you do not list an element twice. So everything that is in y and everything that is in u, and there are two, can you see, but you only write it once. Then the second one is the union of x and z. Again, the same thing. You list everything in x and everything in z, but you do not repeat the 4 and the 6 twice. Thirdly, we want to find the union of y and z. So we list everything that is here, and it's basically all of them. They do not share, except the 7, anything else. Now, we want to find the intersect of x and y. So what does x and y share? As you can see, looking at x, there is a 2 that they are sharing. And what does x and z share? You can see that they share 4 and a 6. The intersect of y and z is going to be what is in y that is also in z, and it's only that 7 on its own there. So the next part is basically just going to ask you the number of elements that you find. So you use this in conjunction with the previous slide. You realize that when you look at the union of the two, there are 7 elements. When you look at the union of x and z, when you have done that on the particular slide, you realize there are 6 elements. The number of elements is equal to 6. So the members of the union of x and z. The number of the intersection of x and y. So you can quickly see x and y. Remember, they're only sharing a 2, so it is only 1. And what is the number of the intersection of x and z? What do they share? They share 4 and a 6, so they only have 2 elements in common. So let me bring in a totally different example, 8 here. So it says in a class of 24 boys, 16 play football and 11 play baseball. If two play neither, that comes outside, remember, in the rectangle there. How many play both games? So let me bring in, and what I like to do is I like to list or label my set with the number of elements that particular set has to contain. And the first thing is I do not know how many of them play both, so I am then going to use the letter X. So in this particular region, I'm going to say 11 minus whatever it is that they play both. And in this particular part, I'm going to say 16 minus this X. Remember, the 2 that are not playing both will therefore come in this region. So this is how I then set it up as I was just explaining. Now, what I know is that if I add all of these universal sets should give me 24. If I add everything, should give me 24. And now I'm just dealing with an equation that I can solve. And once I solve this equation, I'll realize that x is equal to 5, therefore meaning the 5 play both games. And this is one of the very important ways and methods that you can use to solve this particular question. There's a second method, but I kind of like this method a lot because it allows you to create the equation. Anyway, in the second method, they obviously take away the 2 that is in the outside, therefore you only have 22. So the union of f and b must consist of 22 elements if you take away the 2 that is there that neither one is doing. So that means then if you take 22 and you subtract 16, okay, so you take that 22 and you subtract 16, that's going to give you the 6 that you will have. And that particular 6 that you have here is this particular value here. So now you know also from just doing that in that particular set, as I said before, the elements in this set is supposed to be 11. So if it's 11, then you can find this by saying 6 subtracted from 11 gives you 5. That's how you can do this particular question. Since it's a straightforward question, it's not a difficult method to do. In this example 9, what I like to do here is I like to take a question that you typically find in your examination. So it says in a senior class of all 29 students, and this is very important, the all 29 students, they take one or more of biology, chemistry, and physics, which means that there are not going to be any learners or students who don't take neither. The headmaster is informed that 15 take biology, 15 take chemistry, and 18 take physics. Then further information is 10 take biology and chemistry, 5 take chemistry and physics, and 7 take biology and physics. We want to find out how many students take all three subjects. So what I've done here is, you see that when I label my sets, I tend to put the number there as well. So I know exactly how many elements are in this particular set. So I know that set C will have 15 elements altogether. And I also know that there is not going to be any value on the outside of these sets because the all 29 learners take one or more of biology, physics, and chemistry. So I like to start off always with the unknown. So let X be that number that represents the learners or the students who take all three subjects. Okay? So let me just bring that question back again. Remember, I said the X represents all the learners who are doing all three of the subjects. And what we also know is that the 10 learners are doing biology and chemistry, but they do not do physics. So biology and chemistry is this particular region. So we're going to say 10 minus the X, the number of learners who take all three. Very important. The next one says 5 learners are doing chemistry and physics, that is chemistry and physics, but not biology. So it's this particular region here. Again, 5 minus the X, representing all the learners doing all the subjects. And then 7 learners are doing biology and physics, but not chemistry. So it's this particular region here. So what is left is for us to find the remainder of what comes inside the rest of the sets. So we know that, for example, for biology, there are 15 learners altogether doing biology. So in order for me to then find what I will be left with an X, is going to be addition of this subtracted from 15. And that gives me X minus 2 when I do that. So similarly, for the chemistry will be the same. I'll be taking 15 minus what I have here already in order for me to determine what is the missing value I have here. In that particular case, you will see that you get an X. So here again, I want to find the learners who are only doing physics. So I will have to take all the other ones doing the combinations subtracted from 18. And when I do that, I get X plus 6 or 6 plus X. So the other important information is that I know that no learner is not doing neither. All of them are doing chemistry or biology or physics or a combination of biology and physics, chemistry and biology, or chemistry and physics, or all three subjects. So that 29 that I was emphasizing in the beginning says that I only have a 0 here in the rest of the rectangle and the rest of the universal set. All the learners are accounted for. So from here onwards, we can take the union of all of these sets and then we can equate that to 29. And in order for us to calculate the value of X, and once we find the value of X, that tells us how many learners or students are doing all three subjects. So I'm going to bring my diagram back again. So again, as I was saying, I'm going to add everything together and we'll let that equal to 29. And if I clean this up here, if I collect all my x's to one side and all my numbers, I'm going to be left with x plus 26 is equal to 29. And for x to be alone, you realize that you're supposed to subtract the 26. Therefore, x is equal to 3. Therefore, the number of learners who are doing all of the subjects, all three of the subjects, is 3. Right, I hope that you have learned quite a few pointers from the video. The next presentation that I'm going to upload will be based on further examination exercises, similar like the ones towards the end of the current video. Don't forget to subscribe to the channel and click the notification bell